Hello all, we are learning the Simulink library blocks. In that we are started with ports and subsystems. So in a ports and subsystem, just now we have completed what is subsystem, why we are using subsystem and the important types of subsystem. Now before going to start with conditionally executed subsystem, we have to just know more about the conditionally used block. Okay. So these the conditionally used block are enabled, trigger and function call. Okay, so here we can see now. So in that first diagram, I have a one input, output, and subsystem. So the input block are ports that serve as link for outside a system into the system, where the output blocks are outputs for the subsystem. Okay, this for the subsystem, this input and output should be used, or we can directly give constant or a from workspace also if we want. Okay, a subsystem block represents a subsystem of the system that contains it. Here. Okay. So now let's know about the enable block. So enable blocks adds an enable block to a subsystem to make it enable subsystem. Okay. In that subsystem, if we added the enable block, then it will be work as an enable subsystem. Once we will see the example, at that time we will get to know more about it. So enable subsystems are subsystems that execute at each simulation step where the control signal has a positive value, and a control signal is a signal that determines whether a subsystem execute. An enabled subsystem has a single control input which can have a scalar or vector values. If the input is a scalar, the subsystem executes if the input is greater than 0. For instance, if the signal is waveform, sine, like sinusoidal wave, square wave, or anything. So cross zeros and the slope is positive. The subsystem is enabled if the signal crosses 0 and the scope become a negative. Fine. So the subsystem is like disabled in that way. If the input is a vector, the subsystem executes if any of the vector element is greater than 0. At the start of the simulation, Simulink initialize the state of block inside an enabled subsystem to their initial conditions. When an enable subsystem restarts, that is, it executes after having been disabled. The states parameter determine the status of block contained in the enable subsystem. Thus, reset resets the states of their initial condition, like 0 if it's not defined. Okay, if it's not defined, then it will be reset to the 0. Held and hold the states at their previous values. If we have selected held and hold, then it will be like to the previous value, it will be hold and it will again start with the previous value. Okay, so we can output the enabling signal by selecting the shown like output port checkbox in a block parameter dialog in the block parameters dialog blocks. Okay, so selecting this option allows the system to process the enabling the signal. In that way we can select the enable signal. So I'll take here one enable block, enable. Okay, so you can see this is the enable block. Now this is the enable block. So what kind of settings I have shown you here, you can see held and reset I'll be having. If I'll making to the reset, then again it will be going to reset with a 0. If it's a held, it will be starting with a previous value. Okay, here if I'm making reset, then it will start with a 0. And again I will be having option only when enabling or during execution also it will work. Okay, in that way we can select the enable signals. Okay, now next we will study about the trigger. The trigger block is used with a subsystem or a model to allow its execution only when triggered by an external signal provided by the trigger block. We can configure this block to enable a change in the value of the external signal. Okay, to trigger execution, the subsystem can, the subsystem once one each in, in integration step when the value of the signal that passes through the trigger port changes in a specificable ways, like various specific ways we can change. We can also configure the trigger block at trigger block to accept a function call trigger function call, so it will be accept the trigger block, and this allows a function call generator block or else function to trigger the execution of subsystem or model multiple times during the time step. A subsystem or model can contain only one trigger block inside it. Okay, so I'll show you one trigger block. So you can see in that way the trigger block will appear. Okay. So instead also we having city. If you want for a rising edge or if you want for a falling edge, either it may be rising, it may be falling, or it may be function generator. So here we have three options like function call generator or mass serial. So we will be having here. So the place of this block in a subsystem or at the root level of a model to create a trigger or function called system. If the trigger type is rising, falling, or either, placing this block at the root level of a model enabling a signal attribute tables. In that way, it will work. Okay, you can see in the signal attribute table if it's in a rising edge. Okay, so what is the port dimension, what will be the minimum range, maximum range we can do, and we can configure this parameter as well. Okay, so that's all about the trigger block. Now we will learn about a function call. So function like action call generator, we can say that function call or function call generator block execute a function call subsystem at rate specified by the block sample time parameter. We can execute multiple function calls subsystems in a pre-subscribed order by first connecting a function call generator block to like Dmux block that has many output ports as there are function call subsystems to be controlled. So using a Dmux block, we can control many multiple functions also. Thus, we can connect the output ports to the Dmux block and that system to be controlled. In that way, we can control. Okay, the system connected to the first Dmux ports execute a first. Okay, which is connected to the first, it will be executed a first function call block. Okay, and like if various if else conditions should be connected with a function call generator, we can say in that way as well. Okay, so here we can configure the stateflow block to execute a function called subsystems as well, thereby extending the capabilities of the block. So function call generator function call generator block, you can see here, this is my function call generator block. So what kind of functions we are calling to the generator? So the execution of function called subsystem model state flow chart that are connected to this block at a specific rate. To execute a multiple function call blocks in pre-subscribed order, use the block in conjunction with a function called split block. The sample time parameter specifies that rate at which this block execute each function call block connected to it. To iteratively execute each function call block connected to this block multiple times at each time step, use the number of iterations parameter. If we can check like show enable port check checkbox, the block output function call signal only when the input signal to be enabled the port of the positive scalar. In that way it will go. Okay, if we make this show enable port, and it will show the what are the ports are getting enabled with this. Okay, fine. So in that way, so number of iterations we will get here, that sample time it is going disabled from here. It will take a default sample time, whatever from the model. Okay, that's it. So that's all about this tree, conditionally conditional subsystems use these blocks to the executions. Okay, that's it. Thank you.